Okay, we're back on the lathe again, and this time I decided to do the tailstock spindle because it uses the same 1/32 end mill that I used on the other piece, and that's that guy right there. So since I had it out and it wasn't broken yet, I decided to go ahead and start this one. Now this one's a little bit easier because it's less than an inch instead of 4, and it's only 0.025 deep, which is 0.2 of a millimeter less deep than the other one on the other part in the previous video. Now this one gets, well, it's from a 3/32 diameter cold rolled steel, which is this, came in the kit. Now I already did the slot. Because it was pretty much the same as the other one. Notice right there, that'll get trimmed off, obviously. And this is actually, it's 1 inch from that point to here. So I got plenty for the part off tool, plenty to fix that. I did that first before the lathe, so there's less back and forth between the lathe and the mill. And also I figured that would kind of help guide the cutter into the work, maybe. I don't know. Sounds good to me. So again, that's that part done. The next part is to take it to the lathe. And as you can see, that end gets a 3/32 drill, says 5/16 deep, then a taper reamer. And here's the taper reamer. For the kit included taper pin, that will become the dead center. A little bit rusty, got to clean that up. And that just says 5/16 deep. And then drill and tap a 540. Right here, see note 2. There's actually 2 note 2s, and that's kind of my fault because of the way I cut up the drawings to make individual pages. Because on one page, note 2 says to machine a set screw to fit that slot. But on another page, note 2 says this, that the thread should be left-hand thread. So anyways, I do have a left-hand tap and I have a left-hand die. So once I get this one done, I will make this, and that's also out of the 3/16 cold rolled steel. So same material. All of this will be done on the lathe except for the square end here. I'll put that on the mill to do that, but I'll do the lathe work first. But anyways, I'm going to stop rambling. I'm going to set that up in the lathe and drill and ream and drill and tap. And let me get that set up and I'll show you what it looks like. Okay, so with my lathe setup, it's kind of hard to get a good camera angle. That's something I'm still experimenting with. So hopefully you can see okay. I was having a hard time getting it in focus. But this is the part right here. See if I can get that in focus. I think I need to build bigger things because I'm having a hard time focusing. So there's the part. Now this end is supposed to be a 4/0 taper for the taper pin. And as you can see, it's not going in there. It'll start, it'll just start, but that's it. It's not going in any further than that. So the taper reamer that it calls for, I thought I had one. I thought this was it. Because when you compare this to the pin, I mean, I realize I just eyeballed it, but I thought that had to have been it. I'm like, that's got to be it. But apparently, that most outer diameter is pretty much the same as the starter drill for the correct reamer. So that did not work. So I'm going to have to order a reamer. This is one that I've had for years. I don't even remember where I got it. It just ended up in all of my random drill bits. So I have no idea where that came from. So yeah, so now I have to buy one, and the cheapest one I've found so far is like $15 plus shipping. So that kind of sucks that I got to buy one when I thought that I had one. So that's not that big a deal. Once I get that in the mill, it'll be pretty easy to just go through and ream that until the pin fits in. Now the threads, again, that is a left-hand thread. And the issue with that I'm not sure if I did it right. I don't think I did. Right there, that point. So from there to there is the tapered pin, the tapered ream, and it said to go 5/16 deep. And then from there to there is the threaded section, and it said drill 540, or sorry, it says 38 drill, 540 tap 1/2 deep. So obviously when you look at a tap, unless it's a bottoming tap, which this is not, that first part, those threads aren't going to be usable. So there's that much that you would theoretically have to drill deeper if you want 1/2 inch of usable threads. So in other words, I'm not sure if I was supposed to drill 1/2 inch and then tap, or drill it to where I could tap 1/2 inch. In order to tap in 1/2 inch, I would have had to have drilled it deeper, like into here, which would have interfered with the tapered pin, which means the tapered pin would have to be shorter or stick out longer. But if you just drill it to 1/2 inch and then tap it, your usable threads are going to be a little bit less. And so basically, when I was threading this in, it should have, if I wanted 1/2 inch of threads, it should have pretty much bottomed out the tap. And as it is, it went in about like that. So I'm going to lose about 4 threads of being able to turn this in or out. I don't think that's a big deal. It'll still work. It's just that I'm going to lose a tiny bit of travel. I mean, I could drill in more and tap more, but if I drill in more, I'm afraid I might mess up the threads I already made, and that would really suck. Well, I'm not that worried about it. Like I said, this is just a model. It's not like a functional lathe. It's not like I'm going to have to like move it full travel, so it'll still be fine. So I'm not that worried about it. So this part is done except for the reamed end. Like I said, I have to order a reamer. But I want to go ahead and start on the next part, and that would be this. And it's going to be made out of the rest of the stock here. So that gets chucked up in the lathe. And I'm really kind of debating order of operations here. I think what I'm going to do is turn Well, I'll turn the outer diameter first. I'll turn the whole thing to the correct outer diameter there. Then I'll turn that, and then I think I'll take it out of the lathe and put it on the mill, and a four-sided block collet on the mill to make the flats, to make the square end. That way I can hold it in a collet on that end and not worry about messing up the threads. Then I'll flip it around in a lathe holding it by here to do the threads. So that's the plan. Like I said, I'm having a hard time with the camera on the lathe, so I don't know how much of that I'll record versus just show you at the end of each step. So let me get that in the lathe and we'll just go from there. All right, so here's that piece back in the lathe. I got the end turned down to the correct dimension, and then I'm threading the 172 tap into the end of that. And then the next step is I put that in a 4-block collet in the mill and setting that up to mill the square end. And there's the end with the square milled into it. And now my collet block is a cheap China one, and I noticed that when I flip it over, I have to reset the Z. It was off by like almost 0.5 millimeter. I don't know if that's normal or if that's just because I got a cheap one, but not too big of a deal, just a little bit of annoying, but that's the end all milled down and ready for the lathe again. So back in the lathe, I got the other end turned down for the correct diameter for the 540 thread. So after that, I just part it off to the right length and then flip it around in a different collet, and then I can tap the 540 thread. Just another view of it, and so yeah, you got the square end on the right, and then a little shoulder in the middle there, and then a little over 1/2 inch turned down for the 540 thread. And that's the die in my new die holder. I'll show you that a little bit better later on in the video, but that's just getting ready to thread the end of that. Here's that part off the lathe, and we got the square end. Got that end tapped for a 172, which was a little nerve-wracking because for me that's a small tap, and I've never tapped a hole that small in steel, so I just took my time, went slow with it. But the square came out really nice. I'm very pleased with that. And there's the left-hand threads on that end, and those came out pretty nice too. So obviously there's a little bit of area with no threads. That's because the die, you can't go all the way to the shoulder because of the lead-in section of the die. Now, once I got those on there, I went to thread it on here. Oh, and you'll notice you can see the marks of the threads at the bottom of the groove there. I'm not sure if that's because I cut the groove a little bit too deep or if that's just normal for what that is. It doesn't affect anything. It doesn't hurt anything. But when I went to thread that on, it only went on a little bit, like maybe that far, like about that far, then it just kind of stopped. And so what I did was, remember I was talking about not knowing how far to drill or tap because I didn't want the threaded area to interfere with the tapered area. But I did notice that after I cut those threads, the threads are pretty much exactly 1/2 inch. And it said to tap 1/2 inch deep. So I'm under the impression they want all of those threads to go inside of there, which means you have to drill deeper than 1/2 inch for the tap to fit. So I re-drilled at the risk of damaging the threads. Fortunately, I did not damage the threads. I very carefully re-drilled deep enough to thread all the way in, and it still did not want to go in there. It went a little further, but not far enough. So the die is an adjustable die. So I backed that screw out maybe half a turn. I also got to use this new tool that I got. This is to hold dies, and it'll hold two different sizes. You can put a die in that side or that side. And that's a Morse 2 taper, so that goes right into my tailstock. And so you can put that on there, and that little handle, you can pop that out. For as small as that is, it did not need that handle. And that just holds your die, and you can get it started nice and straight. And I got that from a little machine shop, I think. It was at the Model Engineering Expo in Pennsylvania this past year. So they had a little booth set up, and this was not that much money. I mean, it would have been an easy thing to make, but I mean, you know, you go to shows like that, you're in the mood to spend money. So anyways, that goes in there. You have set screws opposite side. So, you know, you loosen the screw here, put that in there, and then when you squeeze those screws down, it squeezes that die down. So I just loosened that screw maybe half a turn, put it in there, did it again, and that was the ticket. That makes it, that made it pretty much perfect. So this now, again, left-hand thread, that now goes in there pretty much all the way, almost. I got one thread left, but I'm calling that good. So this part is done. And I ordered a taper reamer for this. Once I get the taper reamer, I'll ream that open for that, and then I'll turn the point. That'll be the dead center. And I'm going to ream it. I'm going to do it to where, just like on the real one, once that is screwed in, that last thread, I want it to pop out the dead center. So I'm going to ream it, so hopefully that happens. And this then all fits in here. That's the tailstock. Obviously, that's just the raw casting. I have not done anything with that yet. I would really love to bore that out and put that in there so I could have a functional thing, but I'm assuming that the exact location here is determined by how much I mill here. I don't know yet. I have not even looked at the prints or the instructions for that yet, but I definitely don't want to get ahead of the game. But obviously from here to here has to be the same on the tailstock and the headstock. And, you know, this gets machined to fit the bed. And there's a lot of unknowns here that, like I said, I haven't even really thought about that much yet. So this is a problem for future me. But I just wanted to knock those parts out because they were quick and easy. And like I said, I had some downtime on my other projects. So I'm going to call those done for now. I don't know when I'll get back on this build. But that is going to be all for now. I know it's only a couple of small pieces. And for most people, those parts probably wouldn't be that big of a deal. But these are pretty much the smallest parts I've ever made in steel to any amount of accuraciness. So I'm very proud of those, very happy with those, the way they turned out. And I know sometimes it can be hard on camera when you're zoomed in to tell exactly how big or how small something is. So here's just a random coin I found on the sidewalk for scale. And yeah, like I said, I'm going to stop rambling. I'm going to end it here. And as always, until next time, thanks for watching.